Let's continue developing our channel by adding a detail screen to it. Our channel's current user experience, where content is launched directly into playback, is ideal for short-form videos and live linear streams. However, for movies, television shows, and TV specials, we want to display a detail screen that provides more information about the content that we've selected. The detail screen typically includes the item's release date, rating, genre, cast, and detailed description. It also includes a play button for launching content into playback. The detail screen enables users to confirm that they want to watch the content that they've selected. In this lesson, you'll learn how to build a detail screen using more complex SceneGraph components that include nested children. You will learn how to create a button that launches the video player, populate the detail screen with metadata that is stored in other components, and switch the focus when the detail screen is opened and closed. Once again, the first thing we're going to do is to clone the previous example. So let's copy the video player example, paste it, and rename it Detail Screen. Now let's expand the Detail Screen folder, expand the Components folder, and then create a new folder and name it Detail Screen. This is where we're going to create our new Detail Screen component. The Detail Screen contains a layout group that includes a rectangle and poster for the content item's thumbnail, and labels for the item's title and duration. And it contains a group node that includes a label list for the screen's play button, and a nested layout group with labels for the item's description and release date. To create the detail screen, open a new file in your text editor or IDE and create a component named Detail Screen that extends the group component. This component's initial focus will be set to the play button, which is represented by the buttons component that we'll create in a moment. And also will include a reference to the SceneGraph XML schema. Let's add a script element that points to the corresponding detail screen BrightScript file, which we'll create in the next step. Also, we're going to make a small optimization. We're going to move the code that transforms the content duration from seconds to the minutes second format into a separate BrightScript file in the source folder named utils. We'll make that change in a bit. Now we need to create the interface for the detail screen component. So let's expose the detail screen's content field, and then expose a few other fields. First, let's expose the jump to item field, which is an integer, enable the always notify attribute, and call the onJump to item handler when the jump to item field gets updated. This switches the focus in the detail screen to the item that was selected in the grid screen. Also, let's set its default value to 0 so the first content item gains focus by default. Next, let's expose the item focused field, which is an integer, and enable the always notify attribute. And finally, let's expose the button selected field, which is an integer, and set its alias to the item selected attribute of the label list component that we'll use as our play button. Now let's add a set of child components to create the detail screen UI. First, let's add a layout group node to arrange a number of child UI components horizontally in a row from left to right. For this node, we're going to set its translation field to position it. Set the layout direction to horizontal to position its child components in its row from left to right. Set the horizontal alignment to right to set its x-coordinate origin to the right edge of the last child component. And set the item spacing field to put 40 pixels of space between the child elements. Now we're going to add a series of child elements to the layout group. The first is a nested layout group that we're going to use to display the thumbnail for the selected item and its title and duration. We'll add a rectangle with a poster and 2 labels for this component. We'll set the item spacings field so that we've got 14 pixels of horizontal spacing and 10 pixels of vertical spacing between the rectangle and labels. Let's set the layout direction to vertical to position the rectangle and labels in a column from top to bottom. Now let's add the rectangle and its poster and 2 labels. First, let's set the width and height fields of the rectangle and set its color to yellow. Now we'll add a poster on top of the rectangle for displaying the thumbnail. Let's set the width, load width, height, and load height fields of the poster. The load width and load height fields preserve the aspect ratio of the poster image while it's being loaded. Let's set the load display mode field to limit size to scale the image while it's being loaded into texture memory so that it doesn't exceed the load dimension we specified. Now let's add the first label for displaying the item's title. Let's set its ID to title label, set its width, set wrap to false to display the title in a single line, and align it to the right. And now let's add the second label for displaying the item's duration. And we'll set the same attributes. Set the ID to time label, set its width, set wrap to false to display the duration in a single line, and align it to the right. And this finishes the nested layout group. The next child element we'll add to the parent layout group is a group component that we'll use to display the play button for launching the selected item into playback, and displays the item's description and release date. So we'll first add a label list for our play button. Let's set its ID to buttons. If you recall, this is a field we're exposing as part of the detail screen's interface in order to handle the play button being selected. Let's set the number of rows to 3. Add 10 pixels of vertical space between rows in the item spacing field, and set the dimensions of the row in the item size field. Next, we'll add a layout group that will contain the labels for the item's description and release date. Let's set the item spacings field so that we've got 40 pixels of space between the labels, and position the group of labels. Now let's add the first label for displaying the item's description. Let's set its ID to description label, set wrap to true, and max lines to 6 to enable the description to cover up to 6 lines. Set its width. And now let's add the second label for displaying the item's duration. And we'll set the same attributes. Set the ID to release label, set its width, and set wrap to false to display the release date in a single line. And that's it. Our detail screen UI is complete. Let's save this file and name it detailscreen.xml and save it in the detail screen directory. Okay, now that we've completed the UI design for the detail screen, let's program its behavior in its BrightScript file. So let's create a new file in your text editor or IDE and create an init function to initialize the detail screen and its child components. In the init function, we'll first create one observer to monitor the visible field of the component at the top of the scene. When the detail screen becomes visible, the onVisibleChange handler is called to set the focus on the play button when the detail screen is opened. And we'll create a second observer to monitor the item focused field. When a video in the grid screen is selected, the item focus changed handler is called to populate the detail screen with the item's metadata. We'll use the m.top reference to find the components in the detail screen based on their IDs. We'll store these in object reference variables that use the m.attribute, which makes the variables accessible to the whole component. So we'll do this for buttons, which is the label list we'll use for the play button, poster, which we'll use for the thumbnail, description for the item's description, time label for the duration, title label for the name, and release label for the release date. We'll create an empty array named results and iterate through the items in the button's label list and assign them names using an array. For the detail screen, we're only adding a play button, so let's just add the play button to the results array, and then set the content node of the button's label list to the buttons in the result array after it has been transformed into a node using the content list to simple node utility function. And we're done creating the init function. Now let's create the onVisibleChange event handler. We'll use this handler to set the focus on the play button when the detail screen is opened. Let's add logic for when the detail screen gains visibility. When this happens, we set the focus on the button's label list using its setFocus function. And then set the item focused attribute of the button's label list to the value stored in the jump to item field. If you recall, we set this field to 0 in the component XML file because our list currently only contains one button. Now let's create the setDetailsContent method, which populates the detail screen with the metadata of the selected item. This method is called by the onItemFocusChanged handler when an item in the detail screen gains focus. It takes the content node of the item that currently has focus and copies the item's metadata attributes into the corresponding components in the detail screen. So we'll just copy the description of the item and store it in the description label, and we'll use component scope for each node so it's accessible throughout the file. We'll copy the HD post URL and store it in the poster node, copy the time and store it in the time label, copy the title and store it in the title label, and finally copy the release date and store it in the release label. And we're done with this method. Now let's create the onJumpToItem event handler. We'll use this handler to switch the focus to the same item in the detail screen that was selected in the grid screen. This is needed to handle cases where the user selects a video and opens the detail screen, returns to the grid screen after watching the video or pressing the back button, and then selects a different video. So let's store the grid screen's content node in a content variable. If you recall, this variable contains the row of content that includes the currently selected item. And add logic to make sure the jump to item field has a valid value. It should be between 0 and the number of items in the row. Let's verify that the content node is not invalid, jump to item is 0 or greater, and the number of child nodes in the row is greater than jump to item. And if all three conditions are true, let's set the detail screen item focused attribute to jump to item. And that finishes this method. On to the next. So now we're going to create the onItemFocused event handler. We'll use this handler to get the metadata of an item once it has been selected on the grid screen and gains focus. And then we'll use the item's metadata to populate the detail screen. This method takes an event, and we use the event's getData method to get the index of the currently focused item and store it in a variable named focused_item. We then get the metadata of the focused item using the content node's getChild method and store it in a content node named content. And then pass the content node into the setDetailsContent method to add it to the detail screen. And that's done. And we have one last method now. So let's do the onKeyEvent method. This method is used to update the content in the detail screen when the left and right buttons on the Roku remote control are pressed. So this method takes two parameters, the key that received the input and a flag indicating whether it was pressed. Let's set a flag named result to false. We'll use this to track whether the detail screen handled the key press. Now let's add logic for when there's a key press to get the index of the currently focused item and store it in a variable named currentItem. If the left button was pressed, we'll decrement the index and update jump to item with this value. This moves the content to the item to the left, and we'll update result to true because we handled the key press. And now we'll add similar logic for the right button. If the right button was pressed, we'll increment the index and update jump to item with this value. This moves the content to the item to the right. And again, we'll update the result to true because we handled the key press. Finally, let's return the result flag to let the Roku OS know that our component handled the remote control key event. And now we're done updating the file, so let's save it. Now let's incorporate the detail screen in our main scene component. In the components folder, open the main scene XML file. We just need to update the interface of the main scene component by adding the detail screen logic UI script in the UI folder that we'll create in the next step. And then save this file. For the next step, let's create the detail screen UI script that we added to the interface of the main scene component. So, create a new file in your text editor or IDE, and we're going to add three functions. The first function is showDetailScreen, which finds the detail screen node and sets its observers. It takes a content node and the index of the column containing the selected content. This event is called whenever content in the grid screen is selected. When this happens, we want to create an instance of the detail screen and store it in the detail screen reference variable. And then set the detail screen's content node to the row list content node. Set the detail screen's jump to item attribute to the selected index variable of the row list. This way, the item selected in the row list on the grid screen has focus in the detail screen. Now we'll create one observer that monitors the visible field and calls the onDetailScreen visibility changed event handler when it gets updated. This handler sets the focus in the grid screen when it changes in the detail screen. And create a second observer that monitors the button selected field in the detail screen interface and calls the onButtonSelected event handler. This handler opens a video screen when the play button is pressed in the detail screen. And finally, let's show the detail screen by calling our showScreen method. This takes our detail screen node, adds it to the screen stack, and displays it. The next function we need to create is onButtonSelected. It opens the video screen when the play button is pressed in the detail screen. When this happens, we want to use the event loop in our application to get the component that generated the event. So we'll use the getROSGNode method of the event, which will return the detail screen component. We'll store this in a variable named details. Let's get the detail screen's content node, which contains the row of content with a selected item that we'll use as a playlist, and set it to a content variable. Let's use the event loop again. This time we want the attribute that generated the event. So we'll use the getData method of the event, which will return the index of the label list row containing the play button, which is 0. We'll store this in a variable named buttonIndex. And now get the item that currently has focus in the detail screen using the item focused attribute and store it in a selected item variable. Finally, we verified that the play button was pressed by checking if the button index is 0. And if so, pass the playlist and the selected item into the show video screen method, which launches the playlist starting with a selected item. The last function we need to create is the onDetailScreen visibility changed event handler. It keeps the focused items synchronized between the grid screen and detail screen. When the focus changes in the detail screen because the next video in the playlist plays, or the left or right button is pressed on the Roku remote control, the focus in the grid screen is updated to the same item. When this happens, we want to use the event loop in our application to get the attribute that generated the event. So we'll use the getData method of the event, which will return the value stored in the detail screen visible field. We'll store this in a variable named visible. We also want to get the component that generated the event. So we'll use the getROSGNode method of the event, which will return the detail screen component. We'll store this in a variable named detail screen. Let's add logic so that when visible is false, which happens when the detail screen is closed, to get the index of the focused item and use it to update the grid screen's jump to row item field. And that's it. We're done with this event handler. So let's save this file in the components UI logic directory and name it detailscreenlogic.brs. So next, we need to make a few updates to the grid screen logic BrightScript file. So let's open the file. And first, we need to remove line 17 where we set the item index variable, and then change the show video screen method to show detail screen, as that's the screen that now needs to open when content is selected from the grid screen. And let's replace the item index parameter with the m.selectedIndex variable, which represents the video selected in the grid screen. We have one last change before we're finished with the detail screen. When we updated the main scene BrightScript file, I mentioned that we were going to move the code that transforms the content duration from seconds to the minute seconds format from the grid screen BrightScript file into a separate file. So let's do that. Open the grid screen BrightScript file, scroll to the bottom, and then cut the getTime method, and then save the file. Open a new file in your text editor or IDE, paste the getTime method into it, and save the file. Name the file utils.brs and save it in the source directory. So we have one other helper function that we need to add to the utils script. If you recall in the detail screen BrightScript file, we called the content list to simple node method to transform the array of button associative arrays in the detail screen to a content node. We actually still need to define this method. So this method takes an object such as an array and includes a node type parameter, which is a string and that is set to content node by default. We create a node based on the specified node type string, which is content node, and store it in a variable named result. We'll make sure that result is not invalid, and if not, iterate through the object passed in this method, which is the content list that contains the array of buttons in our detail screen. For each item in the content list, which we'll call item AA, we'll create a node and store it in an item variable, set the specified field to the specified value. In our case, this means setting the title field of the first label list row to play. And then we append the node to the result content node. And this helper function is complete, and so is our detail screen. Let's save this file so we can test our channel's new functionality. Great, so now let's test the channel on your Roku device by sideloading it. You can see now that when we select a video in the grid screen, it is displayed in the detail screen. The play button has the focus. When we press play, the video screen opens and playback begins. When we press back on the Roku remote control, the video screen is closed and the detail screen opens. If we go back to the grid screen opens and the last video played in the playlist has focus. And then if I select a different item, the detail screen is updated with that item. Thank you so much for watching this video. For more Roku developer videos, subscribe to our channel. And for the rest of the videos in this course, as well as additional demos and tutorials showing you how to develop on one of the world's leading streaming platforms, check out the link to the Roku Developers video site in the description below.